Hello everybody. Hope you guys are doing well. So like we understood why do we need IP addresses, right? Basically to identify different networks, right? Now we'll see uh, um we'll see classful IP addressing and we'll see how we'll try to understand how and um like how are the IP addresses distributed. Then we will see the drawbacks of splitting every address into a block, and then we'll move on to subnetting. We'll understand smaller networks, how subnetting works, and we'll see masking as well. And then we'll understand why subnetting or masking is a better way to to achieve the same thing rather than using class-based addressing, like class full addressing. So as we studied that every net our modem is going to be the entry point, right? So the modem is the entry point of our network, right? So to identify this network we need an address, and in the early days we had something called as IPv4 addresses, but then these are limited, right? So what we did is we divided these IP address into different blocks based on the size of the organization, how the organization how many address did the organization need. So uh, using that information, we are going to identify the network, right? So now so there are four classes in which we have divided, for example, and we'll see everything in detail. So we divided these IPv4 addresses and as into different classes, right? So this is called into different classes. So and when we did this division, as we are dividing them into different classes, like um as we are dividing our addresses into different classes, uh, this is called as classful or classful or class level addressing, right? Okay, so the first basically class that we have is basically called as class A, right? So first is basically class A sort of addressing. Now so IP addresses are basically 32. So IP version 4 is basically a 32 bit addresses, right? So if you divide it into bytes, so basically we have 4 bytes, right? So and each byte is our we are going to have 4 bytes. So this is first byte. Each byte is going to be of 8. So byte is the bigger part, right? Bit is the smallest part. So we're going to have 1 2 3 4 5 6 7 8 and 1 2 3 4 5 6 7 8 and then one more. 1 2 3 4 5 6 7 8. Now these individual bytes can then be coded. If we are going to represent them in decimal number, so for each byte we have a decimal representation, right? So and then these are going to be separated by dots. So there is a decimal number here a decimal here, and then decimal, and then here another decimal number, right? Now so let's see how we divide into different classes, right? So the first class that we have is basically class A, right? So the first class that we say is class A. Now the class A IP address will start from to 126 point. Now here there is something called as network bits, and let's understand that network bits, and then we have something called as host bits as well, right? Let's try to check what does that mean. So network bits is basically it's going to identify the network, right? So our IP address is designed to function in such a way, the actual IP address. So we need to identify the network and then the specific device in it, right? So we said that our IP address. So then we give IP address in a way that my IP address is network bits. This is used to identify the network, and then I have the host bits, right? So the network bits is responsible for going to that specific network, and then the host is basically to the device on that network, right? So this is device on that network. So now when we go to a class A IP addressing, what is going to happen is so when we are in class A IP addresses, now the first, so the 8 bits are reserved as network bits. So this in class A, what we do is we say 8 bits are reserved for network, and then and then we are having 24 bits as for host, right? So basically what we are saying is, when we allocate this type of IP address, when we have 24 bits for the host, so the number of devices that we can connect is basically so number of devices on that specific network possible is 2 power 24 minus 2, right? Because so in all it's going to be 32. So obviously calculating this 2 power 24 minus 32. Okay, so if you say this as 8 bits, let's say this thing. Now there is something called as network address and broadcast address as well, right? Okay. Now what is this network address and broadcast? Um, shouldn't we know that before itself, or? Okay, let's see how is he dividing. Uh, okay, let's see that. Just give me 1 minute. Uh, okay, let's now. So have we talked about broadcast addresses and uh, okay, let's see. Okay, before we try to understand that, there is some key terminologies that we need to understand, I guess. Okay, so now we are going to learn some. Okay, but So in Classful, there is no subnetting or something like that, right? In Classful, we basically add addresses and then we are having number of devices, right? But then what is he doing is there is something that is missing here. So in an IP address, we say that the IP address is network bits plus the host bits. Network is used outside of the correct network, and then the host bits are used to route data to the host, right? So then now we haven't gone to subnetting. Okay, we'll see that thing later on. So basically, we'll only identify the different classes here, and then we'll try to understand subnetting. Then we will see what is happening here. So then in my class B IP addressing, in my class B, in class B I have so my class A and class A address ends at 126.255.255.250, right? So my class B should start from 128, right? Should start from 127, but then instead of starting it from 127, it starts at 128. So 127, the entire range is kept for something called as loopback address, right? So this is basically reserved for loopback. Now a loopback address allows a computer to communicate with itself. So whenever we see this address, packets are not going to leave the computer. Whenever the OS sees this address, so this is called as loopbacking address. This is the entire range is reserved for that loopback address. Now the using loopback address, what we can do is, so whenever the OS sees the loopback address, the packet, this is like sending a message to the computer itself. So the packet does not leave the OS, like does not leave the computer device itself. Instead it just goes back instead it just goes back to itself. This is like a diagnostic tool to verify. It's a diagnostic tool to verify. So since since the entire 127 range is kept, what we say, reserved, so class B address starts from 128 and go up to so this they will go up to 190. They go to, I guess, 190. Yeah, they go to 191.255.255. Then I have my class C, right? So then class C addressing will be so in my class C I have so that ended at 191, right? So this is 192.0.0. This all the way goes up to 250, 230. Okay, this is 24 bits, right? So this is 223 point okay, yeah, 255.255.255. This is the last address in that range. Then my class D will start from 224 all the way up to 239. And then my class E, which is the last class, that will start from 240 and go all the way to the end, that is 255.255.255. This is the last IP address possible, right? Now so by dividing these into certain blocks, right? Now let's see something called as now we need to find, our goal is basically to understand how many number of okay, so our goal is to define So what we want to find is in each class how many devices can we connect. First is basically to do this, to have to check this, and one more thing is basically how do we recognize our network, right? Okay, now let's see. Now let's go on to something called as subnetting, right? We need to understand that. Let's see subnetting. Now what is subnetting? What is masking? This is where things are going to become a little bit interesting, right? Okay. First, let's understand why do we do subnetting. Like, now the problem is when we are going to do classful networks, right? What are we going to do is basically we are going to allocate the entire range. So if you see in class A, the number of IP addresses that we have is basically so in class A, the number of IP address that we are having right now is 2 power 24, right? So basically that means we are going to have 16,777,216 IP address, right? This is basically 100 like 1 crore 67 lakh IP addresses, right? So suppose if an organization is allocated this, if you allocate this address to an organization, so then an organization has this IP address. Now what is going to happen is the problem occurs is when we only have 500 devices to connect, right? Now only 500 IP addresses out of this is going to be used, right? The remaining all IP addresses are basically going to get wasted, right? So we don't want, there is a massive wastage of IP addressing that is going to happen, right? So by allocating directly by allocating um, blocks of IP address, we are running into a problem. Uh, the problem that we are facing is if what if there is uh, less number of devices connected to an organization, right? Then the block allocated to it. Uh, then IP gets wasted, right? So we don't want this wastage to happen. Yeah, on similar lines, even if you go in, if you say a class B IP addressing again, the problem that is going to happen is the moment you have that, the moment you allocate the entire block, basically we are going to allocate all the IP addresses, and eventually we are going to run in a problem where no IP address is available, right? So this does not happen, right? When we use, like, we can connect any number of devices, like there are billions of people who use internet, right? But still all of them are able to use addresses, right? So the way, instead of allocating blocks, like directly allocating blocks, what we do is basically we perform something called as subnetting, right? Now what does subnetting do is, so subnetting basically um subnet so first, subnetting is basically we are going to break the IP address into smaller manageable chunks, right? So subnetting is basically breaking the IP address into smaller manageable chunks. So breaking IP into smaller chunks. And now let's see the this is like, or in other words, it can also be called as a subnetwork, right? So network is basically when you have two or more computers connected to each other. Subnetwork is like a smaller part of that network, right? So now we are going to avoid. So this helps in avoiding IP wastage, right? Now how does subnetting work? Okay. Now let's see how we are going to do subnetting, right? Now what we do in subnetting is, instead of using the entire address as the network address, what we do is we divide the IP address in, like we split the IP address into two parts. So if you consider like a system, there are two things that we need to identify, right? This is our modem, or basically the entry point to our network, right? So the first thing that we need to identify is this entry point. The next thing that we identify is basically to which device is that packet intended to, right? So what we do is, so on, since we are going, we need to access, we need to identify two things. So what we do is we divide our IP address into two parts. The IP address is going to be network bits plus host bits. Okay. Now what? Okay, and the total size of IP address will be, IP is a 32 bit, right? So the total number of addresses that will be having is 2 power 32. So now what we do is, so first 24, we start with the base network. Okay, so first thing that we do is basically we are given an IP address and we are given network bits, right? So we have an IP and then we have network bits. So for example, this is our IP. So what we do is we have the address written here, and then this. So this is basically reserved for our network bits, right? So if out of total 32, 24 are my network bits, then the host bits are going to be 8, right? So I have 8 host bits. So then the total number of IP that I can have, so total IP possible is basically 2 power 8, right? That is going to be 256. So I can have 256 IP addresses. Now there are going to be two IP address out of this which we cannot use, right? The first one and the last one. Why? Because the first IP address is going to always represent the network, right? So as we said, there are two things that we need to identify. The first address will represent the network, and the second address or the last address will be my broadcast network address. So if I exclude two addresses out of this, then I'll be having 254 addresses available to me. Okay, now we decide how many subnets we need. So I said we are having 254 IP addresses now, and then we decide IP address. So if I want 4 IP address, um, then how many bits we have to borrow? So it's going to be 2 power n. This is like a mathematical things. Required subnets. Then I'm going to do 2. So if I want 4 it, so I'm saying I need 4 subnets. So then this is going to be so if you have this, so if you compare, then my n is going to be equal to 2, right? Now then I do, and then I need to calculate my new subnet mask. So new subnet mask will be okay. Now let's see let's see a little bit more in detail what is happening here and how are we saving IP addresses. Mm, so how does subnetting um, solve the wastage? Like, how am I solving the wastage? Okay, now let's see subnet masks. What is masking? Mm, why do we do masking in the first place? Now, what is the problem here? Mm, there is some issue that we are trying to solve. Okay, so is masking for all. Mm, there is something called as CIDR. Let's see what is the CIDR. This is what is enabling that mask, I guess. Okay, let's see this protocol. This is something. The CID is okay. Interdomain. This is something else. No. Uh, okay. So what we are doing here is okay, let's see IP address and network address and host. So the IP address is a 32-bit address that is used to device a network. It looks like, but just binary. So what we do is the IP address is divided into two parts. A portion of the network that it belongs to, using a bitwise. Why are we doing that masking? I'm not able to get. But for host, we have MAC address, right? But then why do we need IP? Your device uses the IP address to identify which network and the host on that network. Then it uses ARP to find the exact MAC of the host that owns this IP. Okay. The device will then send the frame to the MAC, but it will label IP addressing. Okay. Mm, uh, just give me 1 minute. The CIDR was an improvement over class, uh, but then so the problem that we are having is, if you allocate an entire block, right? So we are wasting a lot of uh, IP addresses. But then even if it's a class, so even if so the okay, let's see the whole let's see the whole thing that is happening, right? This is my modem, right? So this will be providing. I'll be having an ISP who provides me this. Suppose this is Geo, right? And then these are my devices, right? And then I need to communicate to another. I need to communicate with another modem. This is going to be communication, right? And then this is provided by some other ISP. Say this is Airtel, right? So I'll go through the internet exchange points, and then I'll be having a number of devices connected in here. So these are my devices that are connected. Now once I have so basically what we need to identify, or the two things that we need to identify here is first is basically from which network am I. So this is my entry point to the network, right? This is the entry point. So first I need to identify this entry. Okay, so if I'm sending data to this modem, so I need to identify the entry point of this network, and then I need to identify that specific device, right, on this network. Okay, so what we do is basically we have even in Classful there is something called as an IP address. Okay, so the whole analogy is basically what we do is, instead of, we split the IP address into two parts, right? So the IP address has been so the IP, this is which is a 32-bit address. We split this into two parts, such that one is my network and then the other is basically my host. Okay, now when I say for example, when I have an IP address say 192.168.0.1.0, right? Now okay, so when I now what I now okay, so then I'll define something called as a subnet mask. So if I say a subnet mask, suppose if my subnet mask is say 24, right? And then the IP address that I had is 192.168.10.25, right? So what I will do is, so if I convert this into decimal, and if I convert this subnet mask into decimal, this will be 24, right? So this is the last 8 bits are going to be 0, right? 255.255.255.0. If I add both of them, then what I do is, then what I get is Okay, the last is, yeah, when I add them, then I'm going to get my network address, that is 192.168.10.0, right? So then if I subtract, so this is the original IP address and this is the network ID that I got, right? So if I subtract 192.168.10.25, if I subtract this with, the only difference that I have here is basically this 25, right? So basically this 25 is basically uh, this is indicating which device am I going to, which device is, this is basically the uh, device on the network, right? So to identify the okay, when the packet comes in at the router, right, to identify which network it has to go, it checks the IP and the mask when, and it does their ANDing. So the address that you get after the AND is basically nothing but the network address. So basically the role of masking is, what we do is, okay, so the job of masking is basically to identify the network address, because first we need to come enter the network, right? Is to identify which network am I going to, because the network or the modem is going to be my entry point, right? The modem is the entry point. If we don't have the entry point, then we won't be able to deliver it to that packet. So then, so what router is going to do is, a router is basically going to have two things, right? So it is going to have the IP address and the mask. So when we perform logical AND of IP address plus mask, we get network address. The reason we are going to do this because we can only send one IP, right? Like we can only send one IP address. We can't send the network IP address also in the IP header. So there should be some mechanism by which we need to identify the network, right? Because the data will be requested by the device on that network, and we cannot send the network address. Okay, so the other question that arises is, why shouldn't, why, okay, can we send the network address, then masking is not needed, right? The thing is, we cannot directly, like we cannot send the, because we are not communicating. The reasons why we cannot do that is, first is because it's not the network that we are communicating with. But it's the device, it is the but it is the devices on those network, right, that communicate. like we need to reach the destination. We need to reach the destination host, right? Not just a group. So even when routers forward packets, they forward to a network, but they still need to know the full IP. Um. Uh. So then, yeah, because the thing is, we always send a host IP. The reason is, if you think it this way, it's not the network that is going to communicate, right? It's the device on that network that has to talk, right? So, for example, if I have a modem one, and then so even if I the communication has to occur between these two devices. It's not between at the network level, right? So we can only send one thing, right? uh like we can only send one thing, but then routers need to know the network. So if the data is coming from this end and trying to enter, first thing we should know is the network, right? So there is some mechanism that should give us the network address, and that is nothing but masking. So masking is basically a generalized way for us to obtain what the network name is, what the network ID is, so that we can identify the network to enter the um, to enter that specific network, to select the uh, device on that specific network. So for that, first we need to know what network are we entering. Okay. Mm. Okay. Yeah. So that is all for this lecture. I'll see you guys in the next one. Till that time, take care. Bye bye.